This video is about creating function rules and evaluating situations and interpreting multiple representations of a situation. So today we're going to look at a situation given to us and create a multiple representation diagram. So in number 1, Warren Sports Awards is catering Germano's Pizza. Warren pays a $100 fee to place the order with an additional $5 per student attending the award ceremony. Fill in the verbal, numeric, algebraic, and graphic representation below to show the situation. So when we're looking at this situation, we're seeing that there are two things that are happening. They are paying for pizza to come, and it's happening per student. We can also look at the numeric representation in the table to help us figure out our independent and dependent variables. So remember, the independent variable is what we're putting into the situation or what happens first. So our independent variable would be the number of students. And our dependent variable is what happens depending on the independent, which would be our cost in this case. So when we write our dependency statement, remember it's the dependent variable depends on the independent variable. So we would say the cost depends on the number of students. So in our numeric representation, then we're going to figure out what the cost is based on given number of students. So if we have 50 students that are going to come to the award ceremony, remember that it was a $100 fee to set up the order plus $5 per student. So we're going to do 5 times 50. So we can use our calculator for this. 100 plus 5 times parenthesis 50, and that gets us $350. And then we're going to do the same thing for 100 students. So it's $100 plus 5 times 100 students. So 100 plus 5 times 100 students. And that gets us $600. And then we can do 100 plus 5 times 110. And that gets us $650. So our numeric is making a table that represents it. Algebraic is writing the equations. Remember, we have two things here. We have cost and student. So we need to figure out what variables we're going to use for each. So I'm going to use C to represent cost. I'm going to use S to represent students. And I'm going to write an equation with them. So the cost, the dependent variable is by itself. So cost is equal to, it's $100 to set up the order plus 5 per student. So we're going to do 5S. Then in the graphic, we're going to draw a graph that represents our situation. So remember, when we draw a graph, that we need a title. So we're going to say Warren Sports Award Night. Then we need to label our axes. So remember that the independent variable goes on the x-axis, which would be our students. And on the y-axis is going to be the dependent variable, so our cost. So if we go back up to the table so that we have our 3 points, notice that the students are 50, 100, and 110, so we need to figure out a way to count up to that. So I'm going to count by tens on the x-axis, so I need to make sure I have enough space for all of them. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Then for my cost, if I look at my cost, it's 350, 600, 650, so I'm going to count up by 50s on my cost. So on the y-axis, I'm going to start at 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, and 650. Now I'm going to plot my points. Remember, for 50 students, it cost us $350. So we're going to go 50. Let's see where 350 kind of would line up with that. Place a dot. For 100 students, it costs $600. And for 110 students, it costs $650. Then we're just going to leave these dots We're not going to connect them because in this case, our students, we can't have partial students coming to the awards night. So we're just going to have dots representing our points. We're not going to connect them into a line because of our domain and range, which we'll talk about after our first quiz. So let's look at another situation. Animal Shelter begins a fundraiser having earned $150. Each day that goes by, the shelter raises an additional $20. Fill in the verbal, numeric, algebraic, and graphic representations below the situation. So the independent variable, they're collecting money, which we're going to call the donation, and they're doing it in a number of days. So remember, the thing that happens first is the independent, or the thing that we can't have any control over, is the days. The dependent variable is the total donation, because it's growing as the number of days grows. So our dependency statement would be the total donation depends on the number of days. So in this case, they've already filled in the number of days with 4, 8, and 12 for us. So we know that they start with $150 plus $20 per day. So we're going to do 20 times 4. So 150 plus 20 parentheses 4 would be 230. And then we're going to do it for 8 days. So 150 plus 20 times 8 is 310. And we're going to do it again with the 12 days. So 150 plus 20 times 12, which is 390. Then we're going to make an algebraic representation. So remember, we need a variable for each of the independent and dependent. So we're going to say that the T is going to represent total donation, and D is going to represent days. Remember that we can't use the same letter. That's why I didn't use donation for days. I used it for days instead. So you can only use the letter once. So we're going to, in this case, have the T, the total donations, is equal to $150 that they already started with, plus 20D, because it's 20 times $20 per each day. So in our graph, the title we're going to say then would be Animal Shelter. Remember that this corner is 0. So on the x-axis, we're going to have days. And if we look at our table, this time they're all counting by the same thing, 4, 8, 12. They're going up by 4, so I can just go up by 4s on my graph. So we have 4, 8, 12, 16. Then if I look at my money, I'm in 230, 210, and 390. So I'm going to count up for my donation, my total donations by 50s. So I have 50, 100, 150, 200, 250, 300, 350, and 400. So when I go to plot my points then, I'm just going to do my best to estimate a little bit. So at 4 days it was 230, so 4, 230, we're going to put a dot. At 8 days it was 310. And then at 12 days, it was 390. Again, I'm just going to use dots for this because we're collecting donations once per day, so we're not going to connect the line because it's not, we can't use the fractions. And we'll talk about that again with domain and range after our first quiz.